How many of you all saw can solve number 4?
I did.
Did you try to solve number 4?
Yes.
Prince?
Let me open up a question. I'm not sure which one that is. That's when R, like, use B circle.
Huh?
You use B circle.
You do R, then V circle, then T.
Yes, exactly. So it's that formula, just substitute that formula. You see V circular is equal to root of?
Mu over R.
Right. What is mu here?
You look at the appendix.
Right, but what mu does it correspond to?
The radius of the spacecraft.
Mu, Jessica. Mu is not, yes, of what body? That is what I'm asking. So mu, if you look at the appendix itself, there will be various. Yes, that's what I'm asking. Mu is the mu of the moon. So this is a lunar spacecraft. You understand?
Yes.
Circular orbit of the moon. Okay, so the central body, the mu corresponds to moon. Okay. How about 5? Anybody tried 5?
I had a question about the concept of this one.
Yeah, I wasn't even looking on the internet. I seen the formula of like triangle A.
Don't look at the internet. Look. Did you look at the textbook?
A little bit. That's weird. So I'm trying to find out.
In the textbook, I found that T equals pi AB. I don't understand how that comes apart. Does that come from when you do the T equals 2 pi over square root of mu? Are those equivalent? Are the two related or no?
So what is the formula?
To solve it, you just put like it's asking for the area A swept out, T over 3, so you just do the area of A divided by 2 times little t, which would be T over 3.
What is the relationship? Number 5. Just look at this. What is given T is time period is?
T over 3.
Okay.
No, it's
It's the other way around,
It's
right?
big T.
Yes. Right.
You need another marker.
I think it's like this. The T is equal to T over 3, right?
Right.
That makes sense. So the time period is 1/3 of an orbit. What is this T?
The whole time.
The
The whole orbit.
orbit period.
This will be one orbit period. Okay. So this time period, we're trying to find out what is the
Area A swept out
Yes.
during that time period.
right. So here, what is the area of a circle or an area of an ellipse? Huh?
That's a circle.
What is area of a circle? Pi r square. Right? What is the area of ellipse?
Divided by 3.
Or is it the same thing? Oh.
We go 3 halves.
This is over. Pi AB.
Yes, it is pi ab.
Oh, I said that right.
Does it make sense?
It's
Pi ab.
over 3 or is pi?
Why 3? Try to connect. It is so simple. Okay, pi r square, right? That is pi r into r. What is A for a circle?
This radius?
R.
Yeah.
What is B for a circle?
R.
R. You see that?
2 radiuses times
Pi AB is equal to pi AB is simply area of a ellipse. Pi r square is pi r into r. You see that?
Yeah.
You see the correlations of how simple it is?
Yeah.
Right. So here, what do you know from Kepler's, this is number 5, okay. Kepler's second law.
What did we learn from it?
Yes, what does it say?
That the time required to cover certain distance. No,
Go back and review, just tell me the listing. I gave you the statement. Look at the statement and tell me what is third law. What is the second law?
So the planets orbiting around the sun trace equal areas and equal times.
Equal areas in
Equal time.
equal times. Okay. What is the area swept in time t? Area swept when t equal to t for an ellipse.
IAB.
Yes.
So it's a full.
You see that?
Yeah.
Everybody sees this?
Say that again.
Area swept in time equal to the time period of the orbit is the complete ellipse,
Yes.
right? Area is pi AB. What is the area swept if this is for ellipse? What is A for circle?
Fire square.
Huh?
Fire square. Fire square.
Yeah. Does this make sense to you? It's very simple, very straightforward. In one time period, it sweeps one area.
During that time period goes pi over 3 AB.
Yes, that's what it is. You see it?
Yes.
In t equal to t, because that is the law, right? So in area swept, in time, and this is what your conceptual understanding is. This is what needs to, in t equal to 3 is simply does that make sense? Everybody?
Yes.
Jalil,
Yes.
try not to be on cell phone.
I'm working on.
Right.
Huh?
Yes, so does this make sense? Yeah, that's right. Does this make sense?
Yeah, so you, I'm sorry. So you basically saying like the third of the way that's what you're covering over the 3.
The law says
Yeah. Alright.
area swept is proportional to equal areas are swept in.
Equal time.
So let's say take this classroom. Okay, if this classroom you sweep equal areas in
Equal time.
equal times, right? If you're able to sweep the entire classroom, sweep. Okay, and that is what it is. It is sweeping simply in 3 hours. 1/3 of the classroom. How much time will it take?
The third of the 1 hour.
1 hour. That's what it says. You see that? This is the area, this is an ellipse. If you're able to sweep this in 3 hours, 1/3 of the time, how much area will you be able to sweep? 1/3 of that. That's it. That's it. Okay? You can also do this by formula, but I don't think you need to really look at the formula. Okay?
Yes.
Let's look at the next one. Sixth one. So this is optional, but I want you to learn this, okay? Here, an unmanned satellite orbits Earth with a perigee radius of this and apogee radius of that, okay?
This is just plug and chug.
Yes, so if you have the formulas, can you draw this? Can you draw it?
Yes.
Please draw it
Assuming I know it.
as part of your quiz. Draw that ellipse and show me what is that. Indicate apogee and perigee in that. Apogee radius. What is the difference between apogee and apogee radius? What is perigee? It's the point, right? It's a point, okay? Perigee and apogee are the point. Make sense?
Yes.
No, he's talking about the.
Understand the difference. The perigee radius is a distance. Yes. You see that? Perigee is a point. Perigee radius is a distance. Perigee, what is the difference between perigee radius and perigee altitude?
Perigee
the
what?
height of it, and then the
What was the second one?
Yeah, Perigee what?
height.
Pay attention, guys. Evan, pay attention. If I ask you a simple question like, what is the difference between perigee radius, perigee altitude? Will you answer this question in exam?
Yeah.
Perigee radius is a distance.
They're both-
Perigee radius, or perigee radius, or what does it say? Yeah, perigee radius you can say. Perigee radius and perigee altitude. Can you answer this question?
One's
You said
the length,
altitude?
one's the height.
Perigee altitude.
Yeah.
If I give you these,
They should be the same thing, right?
No, on down.
Can you explain it to me?
Yeah, radius of the height.
so pay attention here.
Right?
I'm
That's
honest.
okay. The question is, what is the difference between perigee radius, perigee altitude?
Isn't perigee altitude like the height from your point at zero, and perigee radius is the height from the center of
The height
the
of
orbiting
the
body? Or something?
The distance, don't say the height.
Yeah, the height.
The
I mean,
distance.
Which one are we with?
You got it?
Yeah.
Everybody got it? Gets this?
So, let me try. Can I try?
Yes, go ahead.
So you got the circle and your.
Can I draw it? Or can I-
Right, so let's draw it, okay? So this is your
On the draw.
Earth. Earth.
Yes.
Guys, pay attention, guys.
Alright.
You're talking too much because nobody is able to hear. This is Earth. This is the center of Earth. Okay. This is the orbit. Got it? What is the perigee here?
When you closest
The radius?
No. Perigee is
No,
this
I'm
point.
saying, which one are you asking for?
Perigee.
it's the point
Just
of orbit when you're closest to Earth.
Perigee is this point. What is perigee radius?
The distance between
From
the
the
center
center.
So
body.
this distance is
Perigee radius.
perigee radius. Yes. Or you can say this is
Or
RP. What is this distance?
Perigee altitude.
Orbit.
Yeah, okay.
Got it?
Oh, so it's the difference from the surface of the body. Oh, that makes sense.
So this distance is, if this is Earth, this is, generally I'll use this
That's the radius of Earth.
radius of, this symbol is used. If you look at that appendix, you see this symbol is used for radius of Earth. Does it make sense now? Is it simple? So what is given to you here?
Altitude?
Look at it again.
Radius and apogee radius. Perigee radius and apogee radius.
This point is, this is given.
Yes.
Okay. It should also make common sense. If I give you perigee as 700 kilometers, I'll just say perigee is 700 kilometers. Which distance is this?
Perigee radius.
That's from the surface of the Earth to Perigee. You said 700 kilometers.
That's right.
Can you answer that? That's from the core.
No, not the radius. That's
It
altitude.
cannot be from the core. What happens if it is in the
You
core?
said, wait, run it back. What did you ask?
If I just say, without specifically saying, asking, say perigee is 700 kilometers, apogee is 1400 kilometers. Will you take that as perigee radius or perigee altitude?
Perigee altitude.
Altitude.
Why?
You said it's 700
Just
kilometers
makes
from.
I'll use it as
I'll
a
take
radius.
it as a radius. I would take it as a radius. That's all we're talking.
Why would you go from the surface? Why would you assume that you're going from the surface?
Yes, so 700 kilometers and 1400 kilometers. If you take it as a perigee radius, you know where the satellite will be?
Where?
Inside Earth.
Wait, hold on, time.
I thought perigee radius was less than the radius of Earth.
Yes. The radius of Earth itself is, I think, 6378 kilometers.
Can you can you explain it again?
If I say perigee is 700 kilometers,
Okay.
okay, you should always take that as the altitude. It cannot be the perigee radius.
So you just have to just guess that. Just by
Yes.
the
That
radius.
is what when you, I won't give you things like that, but when you're talking, when you start talking about satellites and orbits. They'll say perigee is 700 kilometers. You should automatically understand that they're referring to this distance. When you go out and talk to folks, they'll say perigee altitude is so much. That is when they won't say perigee altitude, perigee radius. They'll say perigee is 700 kilometers. Contextually, it has to be the altitude. It cannot be, because what happens? Your satellite will be in the core. If you take that as 700 kilometers as the, so here perigee altitude, here it includes both the this distance and this distance.
Another question. So if you talk about radius, the radius always starts on the core? Does the radius always start on the core?
Yeah.
Of course. Otherwise, it is not radius. How is it? Is this radius for anything?
No.
So
It is
I'll
not-
assume that was radius.
Anytime they give me a number and don't specify that it's.
What is a radius? What do you understand by radius?
This is from the center to the.
It has to be from the center. How this will become the center then?
Well, I was thinking like of the orbit, like from the distance from the orbit to the actual circle.
It is not a radius.
Alright,
By definition, that is not a radius,
alright.
right? So this is the radius. It has to go from the center of something. Yes.
Okay, so just a little bit right now, because you said that it would be inside Earth, but it says that the perigee radius is 7,000 kilometers.
Right. So that is this distance.
Okay, so then the.
If I say perigee
the
altitude,
would be like 700 or something.
700. If I say perigee altitude 700,
Okay.
it will be this plus I'll give you this value. You have to have that sense of adding these two together. You cannot do a whole lot of calculations using these.
But we just assume. We assume that let's just give it.
I'll give it to you. For exam purpose, I'll give it clearly.
Alright.
Okay, I won't confuse you in the exam. In the exam, I'll just give it to you clearly. But I'm saying it in conversation with you.
Okay.
Okay. So try to do this. It's all formulas, but what I want you to understand is what does the 700 kilometers and 70,000 kilometers mean? Okay. So here, this distance is RT is 7,000. And this distance will be, what is apogee?
70,000.
So this will be, so this, if you look at this, it will be somewhat like this. Okay, so this distance is
That's after, that's
That's apple.
apogee radius. So, again, in this orbit, the Earth isn't at the center of the focus.
no.
Okay.
It is at the center. You don't say center of the focus. You say focus.
Okay.
Center is different. Focus is different.
Okay.
Foci are different.
It's two of them, right?
Yes. So the Earth is always at the focus, regardless of what orbit you consider. Even circle. Just know that this central body is at the focus. Yes.
Okay. I remember you telling us before that you were going to ask us to be able to draw ellipses and this.
Yes. I still expect you to do that. Especially now that you have more time.
So
You have to figure out.
absolutely have pen and
Yes. Otherwise, you're not going to get credit for it. You can check out YouTube videos how to draw an ellipse. Yes. Okay. Next one. So try to do this. Seventh one is what? Now do the seventh one for now. For me. Draw the orbit schematic of a circular orbit. In whatever way you can, draw the orbit schematic. Come on. Come on, Evan. I need this. This is your quiz, okay? So,
what was the first question?
huh?
It's all.
all of this is going to be your quiz.
Okay.
There you go.
So,
I want you to draw the orbit schematic of a circular orbit.
What was that?
Everything from number 7.
Draw a bigger circle. That's, we won't be able to label those. There are a lot of things you need to label on that. So I need you to label.
Oh, my circle's too small.
First draw a circle or circular orbit. You draw a circle. Draw the foci, draw the occupied and unoccupied focus, or label occupied and unoccupied focus on that. That is what I need you to tell me. Everybody, don't speak out loud. Just note or just identify where you can use your notes if you have it. I don't have a problem. I want you to label occupied and unoccupied focus and the center.
We take points off if we can't draw a good circle. We take points off if we can't really draw a circle.
You have to do some extra work for that, extra credit for that. Because if you cannot draw a circle, you have to go back to art class in middle school and then learn how to play. Huh? Okay, label the semi-major axis and label the semi-major and semi-minor axis. Yes. Label the semi-major and semi-minor axis. Label the first. Label the occupied unoccupied focus. Circular orbit. I want all your listeners quiz to be. Circular orbit. Don't draw this surface of the earth or surface of the central body. Here it is just a point. Okay? This is only for your understanding.
So just do the point in the orbit in the order.
Yes, point in the point. Circular orbit. Circular orbit. We are first doing circular orbit. Yes.
You want the focus and the semi-major.
Focus, like occupied focus, unoccupied focus, center, semi-major axis, semi-minor axis. Okay? We're done with that? Draw the apse line. Apse line is simply the what could be the apse line?
The major line.
Line's on 7 seconds.
Yes, but what is that connecting? Put your logic here. Just think this is what I want you to do. Think what is it connecting? You can say out loud if you know what it is.
It's like
Yes. It is the apse line. It is the line which connects the apses. What are the apses? What are the apses we talked about? Those are the two apses, right? The line which connects the two apses is the apse line. You see that?
Yeah.
So it cannot be.
I mean, but you got the one that's closest and the one that's far off, so but that's connecting, right?
So you cannot have this. You see that? The cross, it is the line which connects the two apses. Makes sense? So apse line, again look at this. Just a minute. So apses, APSIS is what? Singular. Apoapsis. When you write apoapsis, it is APSIS. Apsis, APSIS is singular. APSES is plural. So that is what it says, apse line. Apse line means the line which connects.
What's that one more time?
Apsis, APSIS is singular. Apse line. You mean singular and plural.
Okay.
So that's where you're saying like that.
SES becomes plural. SIS is singular.
So why did you put plural on the paper?
It's apse line which connects the two two axes.
Okay.
True anomaly. Don't worry about this true anomaly. I'll talk about. So true anomaly. I think I need you to know what true anomaly is.
That's the angle, right?
That's the angle. Okay. So here, what angle from what? That is also important.
The central body to the satellite.
No.
Okay.
Okay. Now understand this.
Is it from the
This.
Tilt of the
Yes.
Is it like from the focal point to where the satellite is, so that angle?
What is an angle? Let me test your fundamental understanding. What is an angle? So tell me, define it.
The angle is
How two intersecting lines kind of
What is required for an angle?
two lines intersect.
Two lines to intersect, at least. So two lines is a basic requirement. So it cannot be between two bodies. You understand? Angle does not exist between two bodies.
Oh, you have to have a reference point.
Yes, reference line.
Okay. That's what the apps. That's what the apps.
That's the, so the apps, not just the apps line, but the line, the reference line here is the RP.
Oh, the Perry radius.
Yes, this is the reference line. So depending on where your satellite is, if the satellite is here, this is the
Perigee
perigee. This is the true anomaly. Okay, if your satellite is here, this is the true anomaly. You see that? It starts from this perigee reference or perigee radius. If the satellite is here, what is the angle?
0.
0. If the satellite is here, what is the angle?
It's like 275.
Plus. Yes. So you cannot say this is not the angle. If you say this is theta, no. Okay. The angle is. You got it?
Yes.
Idris,
Yes.
if you tell me if you say the angle is minus this, will you get it right?
Yes.
Yes, technically yes.
Yes.
Minus is okay, but if you just give me that, it is not. Okay? Yes.
Does the direction of the orbit matter? So if it was working the other way.
Right. So direction of orbit, what we do is for discussion purposes, we consider the anti-clockwise as the direction. Okay, which is a prograde orbit. If you look at how satellite is rotating, it's rotating anti-clockwise. You see that Earth is rotating like this, right? So if you look from top, it is anti-clockwise. So we always talk of the prograde orbit, or the orbit which is in the same direction as the rotation of Earth. If it is rotating otherwise, the angle will change. Yes, it will change. It will not be the same. Got it? Does this make sense? True anomaly. Mark RA and RP. Yes.
That's what one of my questions was.
So
Now, based on your understanding market, I have already shown you what RA and RP.
can
But
I?
that's on the ellipse. I had a question about the circle.
Do it whatever your understanding. I want to test your understanding.
So
Don't worry about it. Do whatever you can. Don't worry about it. Just do demonstrate your understanding. That's what I'm looking at. I'll tell you what it is. You'll know what it is. It is not complicated at all. The definition is clear. What is the definition? Definition is here. Just follow the definition of RP and RA. Did you do it? Yeah. Okay. When you have marked your perigee and apogee. Everybody has marked that in your orbit.
Can you tell us how to correct it? That was really one of my questions. Really. Like, how is the circle, if the circle is the same, how is it different? Like, how do you differentiate the two?
You're the same.
So when you draw it, do you place them on the same side, or do you still put them on the other side?
Does it matter?
But it's all the same sometimes.
Wherever you mark your apogee and perigee.
So it's not.
Yes.
Okay.
That's a good question. So it doesn't, for circle, is there an apogee and perigee?
No.
Strictly speaking, it doesn't matter really, but for keeping a track, so why is apogee and perigee? One, it is the closest distance, okay? But it's also, so if this is perigee, every time the satellite crosses this, right, you keep a track of that. It is also a means of keeping a track of when your satellite passes a particular point. You understand? It is, of course, it is the distance or it is the closest point of approach. But if everything is the same, it is also a means of tracking this. Is this relative position going to be the same for an orbit? Even for let's say you take this circle, okay?
Yes.
Right? Is this point, if this is your F, is this relative point going to be the same?
Yes.
Is it inside or is it outside?
This point, let's say I mark this as, does it matter which one I mark as perigee?
No.
It doesn't matter, right?
Are you talking
But
about?
once I mark one point as perigee,
That point is paired like that. It should remain paired.
yes, it should remain the same.
Yes.
You see that?
Yes.
Because is this relative point the same regardless of where Earth is moving? It is the same, right? So it is the same, Jalil. No?
I don't understand that. You mean in reference to the orbit?
Reference to this is where Earth is at the center. The satellite is doing this. I mark as one point as perigee.
Okay.
Will that point be the same?
Yeah, you talking about for reference for the true anomalies?
Not true anomaly, the perigee.
Okay. Yeah, I mean, but wow, you could also call that same point apogee as well.
Yes, so once you mark it, will it be the same? That's what my point is.
Oh, okay, yeah.
Will it be the same?
Yes.
So if you mark your perigee here, you want to mark your apogee here. Depending on,
So it just need to be opposite of each other.
it just convention, okay? By definition, it doesn't matter, but the relative position has to be the same. So if you know this has marked, this has, what does this have? What are you used to, how do you mark this or how do you identify this point? What do you know about, how would you identify this point?
0 degree.
In your day-to-day, until based on your understanding until now, can you tell me a means of identifying this point? How do you identify a point on Earth? Latitude, longitude. Okay. So if you fix a latitude, longitude to this, will that latitude, longitude be the same? So if Earth is moving, right? If you mark one latitude, longitude, regardless of where Earth is, how Earth is moving, that point will be the same, right?
So it doesn't mean like
Outside of our house.
the same spots on the earth.
Yes. With respect to Earth, that point is the same.
Oh, okay, yeah.
I mean, because if the grid's moving there.
If the Earth was flexible, okay,
For the earth, okay, so the earth's tilt and where the moon is. The earth's tilt has no effect on where the moon is in the sky.
yes, no,
Okay.
that's exactly correct. Earth, Moon's orbit is the same.
Okay.
So because Earth is like this, Moon doesn't have to rotate like this. If Earth is like this, right, there's a tilt. Moon can do this. Moon can do this. Okay, you got it? The tilt is just the tilt. So regardless of the tilt has no bearing on
The orbit.
the orbit itself.
Yeah.
You got it?
Yeah, that makes sense.
So once you mark a perigee apogee, it should remain the same for the remainder of the tracking of the satellite. Okay. So mark periapsis and apoapsis. Did you mark that? Okay. Now, last one. Let's do this 8th one and then we can wrap it up. So this here. Okay. So let's look at just. Are you able to solve 8th one? Nomenclature. You understand nomenclature?
Yes.
Identify the terms. What is H?
Angular momentum.
Specific angular moment.
Specific.
What is mu?
Gravitational parameter.
Yes. What is theta?
The angle.
True nomenclature. So I want you to learn that nomenclature or jargon. Okay. It's important because otherwise you cannot call it an angle. You cannot call it H or you cannot call it. I want you to learn that term. That is the nomenclature.
Can you say those again? You said H was.
Here.
Okay. So you'll be asked something like that. So please give me your whatever you have done.